Welcome to another episode of Stratola Spectrum. I'm your host, Dinesh Chandrasekhar, Chief Analyst and founder at Stratola. Today, we are going to be talking about synthetic data. With AI models being built and nurtured across all types of industry verticals, it is pertinent to train those models appropriately with the right type of data to make them work effectively for all types of real-life scenarios. However, real enterprise data may not be consumed as is due to challenges such as data privacy, regulation and compliance, or even that data is just sparse. In these cases, synthetic data needs to be generated to train such models, and generating such synthetic data is no mean feat. To discuss this, we have our guest of the day, Muckai Girish. Girish is the co-founder and CEO of Rockfish Data. He has had an extensive career in marketing, business development, and strategy across various companies such as Juniper Networks, Reliance Jio, Entropic, Vestel, and Aris. He is also an advisor, mentor, and investor at various startups in the Bay Area. So let's dive into the episode. Welcome to the show, Girish.
Hey, thanks, Dinesh. So good to be here. Appreciate it.
Love it. So let's start off with the fundamental question here. Since we are going to be talking a lot about synthetic data, why is data, particularly synthetic data, kind of like the unsung hero, if you will, in this modern AI revolution? I mean, it's kind of critical to like build all these models, but at the same time, I don't think a lot of people are like even recognizing or like talking about it that much. So what is your take on it?
Yeah, it's interesting. A lot of work has gone into developing AI models. As we know, the world is literally working towards developing every kind of model, making it more and more optimized and optimal and all of that. Then suddenly, when we are doing it, everyone realized that the fundamental bottleneck in making AI models work or work very well is data, because models are good for what it is, obviously. However, the data makes the fundamental difference. It's like having car and having either electricity or oil. If you just build a car without a place to put the right oil or right battery, your car cannot go really that fast or that far, right? So in the same way, I think what we are finding is models are needed, and there is tremendous amount of brain power that has gone into it and continue to go into it. But data becomes the fundamental bottleneck. Multiple reasons. One is there is data sparsity, right? You don't have enough data, or you don't have the data that you need. And then number two is data sharing constraints. That happens in some cases when somebody else has the data, I need it, or I have the data, I have to share it with somebody else, and so on. But if you look at sparsity itself, that is a huge issue, because we just don't have all the data that we need a model to do work to work really well. Second is, we also in order to train a model well and make it work really really effectively, you need all kinds of data, not just the data that you have, right? And then there are so many other aspects of it, reliability, robustness, and all of that, where you need more and more data. So that has been a challenge. And unfortunately, real data, if you look at both publicly available data and also enterprise data, if you separate the two, publicly available data, we can always go get access to everything on the web. However, of course, it is computationally intense, and only some companies with a lot of resources can do, but it's feasible to do. In the case of enterprise, it's all very proprietary. No enterprise wants to share its data with anybody else. So if you really want to train a model to work for certain types of enterprises, you really need their data, which is proprietary, and becomes hard. And that's when the role of synthetic data comes to play, where, hey, I want to really get privacy compliant, that is safely shareable data. However, it has to be realistic as well. If it is privacy, you can delete everything, one extreme, and get nothing. That is very private. That doesn't solve the problem.
Right.
But can you now get something that is very realistic? That's where synthetic data plays a big role nowadays in that area, Dinesh.
Awesome. Thank you, Girish. So let's maybe start with the beginning. When did you start Rockfish Data?
Almost 3 years ago, actually, this month in 2022 is when we started. Incorporated the company again with my co-founders Vyas Shekhar and Julia Fanti. They both are faculty members at Carnegie Mellon University. So we had spoken about this a few months prior to that, and eventually, as they say, pull the plug or jumped into this in August of 2022.
Fantastic. So congratulations on getting to 3 years. That's amazing. What is a particular problem that you saw 3 years ago that made you want to do this company in the first place? I know 3 years ago, I think the entire industry landscape changed with the whole chat GPT thing and all that. But was that the trigger, or were you already thinking about this? Were you already seeing this kind of problem of model training and all that?
Yeah, Dinesh, yeah, you're right. I call this BC, before ChatGPT, right? The reason, actually, the reason we got started was Vyas called me one day. This was the first quarter of 2022, so end of March, around that time. And I've known him for a long time, right? He called and said he and Julia and their students have been working on a problem, and they got inspired because of other reasons. They felt there was an reproducibility crisis in academia, right? To quote Vyas, and they saw a paper by Longfellow on generative adversarial networks, or GANs, and that got them started to generate synthetic data. And when he called me with this problem, the problem that they were solving and the solution they have, it resonated because my customers at that time were facing the same issues, and my company at that time, we were facing very similar issues as well. We were really data starved to train our AI models, and our customers were unable to retain data or to share it with vendors like us at that time. So for me, it was just like, hey, here is a problem that I've been experiencing for the past several years, and a fantastic solution brought from Carnegie Mellon University. So suddenly, all our eyes were wide open for a very long period of time. So that's what got us started, actually. You know.
So I think you were almost like foreseeing how this industry is going to change, and you were ready for it. That's awesome. So for the lesser mortals like me who didn't go to CMU, if you were to explain this in simpler terms, is this more like, let's say, synthetic data is like a flight simulator for AI, like where you get to like train on scenarios that aren't like real yet, but once you get to the real world, you get to see these types of scenarios. So synthetic data prepares you for those kinds of scenarios? Is that what the deal is?
Yeah, Dinesh, you've been around the block, and you've seen the industry from so many different angles. And obviously, you have a much phenomenal sense of appreciation for this. But synthetic data, the way we look at it is there are two problems, right? One is privacy problem, and the other one is sparsity problem. And when you look at privacy problem, you're trying to you have some data, I want to share it with you, and because you have an AI model that you're developing for me, right? But I don't want to share sensitive aspects with you. So I can remove or anonymize certain fields that are very sensitive and give you the rest as is, right?
So
That's what.
PII, PHI data and all that. So we are talking about like healthcare type of verticals, right?
Right. And people have been doing that for a while. Anonymization has been there. So the problem with anonymization is twofold. One is if you really want to make it private, you have to delete more and more of things, that means the utility of the data goes down. Second is, even if you delete some fields, the remaining data, it actually is exactly the same as your original data, right? Which means you may be violating not just privacy, but also maybe some compliance things, especially in the regulated industry, right?
Mm-hmm.
So instead, you can generate synthetic data in multiple ways. So you can look at a set of data that you already have, and you can either create a generative model of that. That means I learn all the characteristics of it, right? Here is a distribution of each field. Here is a correlate, how certain things are dependent on each other and correlated, how other aspects of the data, other characteristics of the data, both statistically and qualitatively. Now I can then replicate that or as a sample. Now that I've learned about it, think of it as, I go do a survey and then now I'm representing what their behavior may look like, right? In the same way, you can do this. So generative models like GANs and transformers and diffusion models and state space models and all of that. They let us do this very well today. That means you ingest a bunch of data into it. It can learn so much about it today than it ever was possible at scale with performance and all of that. And then you can redo this or regenerate from there. That works out well, right? And this is very different from model-based generation or simulation, right? In my when I was in grad school in the early 90s, we did a lot of simulation, where you'll say, hey, this is a normal distribution, this is an Erlang distribution, or this is uniform distribution, and generate data from that. And you can do that, right? But unfortunately, what happens is when you want to represent data very similar, it becomes hard to model it based on a particular distribution, right?
Mm-hmm.
I spent my early grad school life actually trying to model these things, and it's a hard problem, right, in general. Because of this AI, generative AI, and generative modeling, we can now do this so well, right? So we get the best of both worlds. One is we can remove the PHI fields, which you need to do anyway, if privacy is an issue, you're sharing it outside an entity. Then the remaining data also, you can make it very looking similar, but yet very different. So it's a kind of a
So change
double-edged
the
sword. You
patient
get it.
names, generate a new set of names and all that or whatever.
Correct, exactly. And then you can also, what happens is you can also add on new things, right? You may not have some data in the original things, but you can now say, hey, give me add on something new. That you can do it either with model-based, simulation-based, or LLMs can generate some stuff for us, right, nowadays. So you're augmenting it, but that one we know that we're not really trying to match it to something in the past.
So pause for a second. I want to get to your data sparsity, comment as well, because I think that's very important. So we will definitely get to that. But just from a data privacy angle itself, what are the types of companies that would typically want to come to Rockfish Data? What are the challenges that they'll typically have in the first place that they go like, well, I need something like this?
Right. So one is if you a lot of companies actually use external vendors to do AI models, predictive models, all of that stuff. And this applies both in enterprise and public sector, right? Second, so for them, they really have to share representative data with another entity, another group, right? So that they can use it to train a model. They can use it to, for example, they could use it for vendor evaluation. So let's say you're trying to pick a vendor and you're
Mhm.
working with 3 or 4 vendors, potential vendors. You want to really give them something representative, and they can run it and then show you, and that you'll use to say which vendor is better, right? Based on that. Or you may want to give, let's say you're testing a new software release. You will have a dev QA team, and you don't want to give them your production data because it's very sensitive, right? So instead, you would really want to give them something that is similar yet very private, right? So that is within the same organization. However, it's being tested on a software from another company which is fully not deployed yet. So you really don't want to share that because of data leakage issues and so on, right? And 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 of course, there is another interesting application is a lot of companies have retention policies, especially granular data, right? When you generate all kinds of telemetry, application performance data, and so on, network data, right? They just generate petabytes of data every day, tens of petabytes or more. You don't know, and most of them don't store that data for more than 7 days or
Correct.
15 days, and so on, right? So what happens is at a later time, if you really want to reconstruct that for whatever reason, you just don't have the data that you originally had, right?
Right.
Because you kind of dropped it. So you want to store them. However, you don't want to store them with all the information that you had in the past, right? There is a lot of privacy elements because the more you store, the more you're risking somebody trying to get access to the data. So you have no clue what happens to that. Second is GDPR and other things where you don't want to keep some of the customer related information, right?
Right.
So privacy kind of comes in so many different ways, and one way to address that is with privacy compliant synthetic data in order to do all of these.
GDPR doesn't directly affect you. It is you're saying more from the retention of the original data. If that gets lost, you are able to compensate for it, is what you're saying.
Correct. That's right.
Okay.
That's right. Yeah.
How much is the typical data volume that you generate when it comes to synthetic data? What's the, kind of size that we're talking about here?
It varies a lot. I'll always quote my accounting professor. It depends,
It depends.
like in accounting. Uh, so if you look at telecom, cybersecurity, observability, those verticals, they generate a lot of data. I mean, you're talking about, 50, 100 petabytes a day,
Right.
right? In many cases.
No, I know what the original volumes
Right.
that these verticals generate.
Right.
Do you, from your perspective, do you generate an equal amount of like data if for some of these use cases that you quoted, if somebody were to like test out like anomalous behavior of a particular device on the network or something like that, and if they need to simulate that, how much data do you end up like generating?
Yeah, Dinesh, that also depends.
Doesn't
But
it?
the one way to look at it is you generate equal amount of data, right, or close to equal amount. But the advantage of synthetic data is you can generate as much as you want. Okay, so let's say you trained it with 1 million data points, right? That's the input. You can generate 1 million data, 10,000 data points, 1 billion, 1 trillion, right? Of course, they will all look similar, right? If you just plainly generate. However, like what you mentioned about anomalous behavior, sometimes most of the data is normal, right? Or something close to normal. But you're only interested in interesting events like anomalies, outages, fraud, and things like that. In which case, with synthetic data, you can create more of those patterns. So you may be really interested in, hey, my normal data is fine. I don't need millions and billions of it, but give me more of the fraud, anomaly, outage, interesting scenarios, right? Events, right? Quote unquote events. That you can generate more. So I think it depends on the application, how somebody is using it. If you're going to use it to train a model, sheer volume is not going to make it better, right? If the data is similar, then you really don't need a lot of data to train better. But if you want to create like variants of it, you want to create, amplify, certain patterns, repeat certain types of things, that is more useful, right? So there's a quality of that more useful than just sheer quantity, actually.
Okay.
Having
We
said
need to
that,
get to the quality conversation as well a little bit. So I'll table that for now. But I want to go back to your data sparsity comment, right? So now that we spoke about volumes and all that, tell me about the data sparsity challenge, because I think a year or two ago, when synthetic data kind of became a concept and everybody was like talking about it, I think this was there even before. Like I used to be an SC like 20 years ago in a different life, and I used to generate synthetic data using like scripts and stuff, so that I could run my demos and all that. So that used to be the thing, not for model training, but now model training has a different scale, different set of needs, a whole new set of factors and all that. So I know we are talking about different things here, but my point about what I was saying earlier is 2 years ago or so when this came about, people actually said there is actually we are running out of real data to train models is what they were saying, right? Is that really true? Like are we really running out of like real data to train models? And then secondary question there is synthetic data, how much does it actually match in terms of like quality and all that to real data, right? So um, how do you address that?
yeah, Dinesh. So one is if you look at LLMs and foundation models, they are using all publicly available data to train them, and they are really running out of data because you just don't have more than what is available, publicly available, right? So there is definitely a dearth of, what else can I use to train it? Because you can only, let's say you get all the books, all the websites, all the publicly available information and train it. And that's what they all have done, all the foundation models, right? But you hit a wall at some point. The marginal data that you can use to train after that is very small, right? So uh, they really want access to more of the proprietary data because the publicly available data sets are just
Right.
you type out. That's it, right? So they have that problem. Okay, number one. The second is even if you look at enterprises where you have more operational data that you use to do things, you are not running out of data to train. It's more access to the data, and also most of the enterprises they are looking for what if scenarios, right?
Mm.
It's not what is there today. It is what happens in the future, right? So, if you look at the autonomous vehicles of any sort, any robot, anything autonomous, right? I mean, you have now these small things, last mile delivery, those small things running around on the side of the road nowadays to self-driving and so on. They are all looking for scenarios they don't know, right?
Yeah.
The sun is shining in this angle. There's a car coming here. There is traffic light not working. Those are very hard because those data that data doesn't exist, right? On the other hand, when you look at operational data, that's a type of data that we address. Using the things that you know that you have, we can actually, using synthetic data, create various data for various scenarios. So let's say in the supply chain industry, you say, hey, I cannot get a certain amount of stuff coming through the Panama Canal, right? So that supply chain is going to be broken for 2 weeks. Then create a scenario of what happens.
Mm.
Now, using the data that you have and using certain conditions, you can now generate synthetic data. We call it conditional generation, right? That is what you would need to basically feed it into your models or analysis to say, hey, now am I going to be in deep trouble, or do I really need to look at alternate suppliers during that time, or my profitability, top line, bottom line, are they going to be hit? How much is that going to be hit if I were to do this? Should I do something else?
Right.
Is it worth it, right? So there's a lot of these business decisions you can make by looking at potential conditional aspects. So that's where synthetic data plays a big role when it comes to sparsity.
Fantastic.
You know,
Have you ever been accused of this, of where fake data can never be as good as real data? Um, my question more is like, what does synthetic data need to have? Like, what kind of properties does it need to have in order for it to be like, statistically representative and useful to train a model?
yeah, this is a great point, right? So up to 2 years ago, there was a lot of trepidation about synthetic data. Everyone thought, hey, it's great, but it's fake data. It won't do much, right? So we operate by about two or three principles. Number one, if you create data from vacuum, then it is as good as what it may be, right? You can't really stand by it. But if you're creating synthetic data from a set of existing data, then there are two ways you can make sure they're good. One is there are a lot of data quality checks that you can do, right?
Mm,
Both from fidelity standpoint and privacy standpoint. So there are standard metrics. You can write custom metrics for each need. Where for example, in the fidelity case, you can say distribution of each field, correlations between each field, correlations between metadata and measurements, time dependencies, how those intersection lengths and all of that behave. There are metrics that will tell you how good the synthetic data is relative to the original data in
mm.
various ways. Okay, that'll kind of give you super confidence that, hey, am I close or am I way off? Right? So that is one. Second is, even for fidelity, what you really want is how does it work in a downstream use case? So if you're generating synthetic data to train a model, you really want to first test using real data how the model behaves, then use synthetic data and test the model and see are they close, right? So if you just don't have the real data at all, if you don't do this exercise, you can never be sure what the synthetic data,
I was about to ask you, how do you even measure the realism in that data, right? So I think that's a great example. Nice.
yeah, and then same thing for privacy as well.
Mm,
There are a lot of metrics, what we call memorization, right? So the problem with synthetic data is you can always memorize the whole thing and repeat. Then it defeats the purpose of having synthetic. Then you might as well use original data, right? So there is a metric called memorization metric. There is a metric distance to closest record. How close? Because you can, let's say, shift everything by 0.0001.
mm,
Your data is different, but they're really close, right? Consistently close, right? And the third is we call inference and linkability, where if I look at at synthetic data, can I infer something about the original data, right? Does it give me enough information to say, or can I do like a membership inference attack, right? Can I just now, ask a couple of things and then now I get the answer, right? Because let's say you have a formula, every third number is sum of the first two. Let's say you put it. I can always infer, given enough data points, with enough algorithms, I can go and infer. That's it. I crack the original data from it, right? Completely. So that, going back to one of the questions you asked earlier, generative models that way are very helpful because
Hmm.
they are creating something that is look-alike yet, quite different.
How much of this is like automated? Is there a human in the loop? And my other thinking is like, data scientists, domain experts, like how do they fit into the loop of like, guiding generation and ensuring that the relevant data is actually, being sent out and all that? What's the process here?
Dinesh, so one thing we realized is if at all there is some effort, it should be only one time. And we deal with data that is really recurrent, right? Time series, transactions, sessions, and all of that. So they happen day after day, week after week, and so on, right? We don't want to do this every single day, right? A lot of involvement by people. But instead, there is a one-time setup, right, where the domain expert, whoever is using it, can set it up and make sure that everything is working well. Second is the way we have designed it is you can also incorporate a lot of domain-specific constraints and requirements, right? So an example would be if you're looking at a car order for a car, the take rate of a feature becomes an important metric, right? Because if you look at heated mirrors in Scandinavian countries versus in California, the take rates are vastly different, right?
Hmm.
So you want to kind of have that knowledge into the system. Otherwise, when you generate a set of car orders in Sweden, you may not get enough of heated mirrors and vice versa, right? So a lot of domain constraints and requirements that you want to put into it, so that the user can actually incorporate, and they are the best judge of doing it, right? And they do it once, use a sample data set, 1 day's data, for example, and then set it all up, and then like what you asked earlier, how good is the synthetic data relative to the real data? If you have to make any tweaking of models and tune
Right.
of that, you do it once. Once you do that, you have everything set. After that, as data comes in day after day, it just goes through, right? Boom, boom. There's no human involvement. The only time there is once in a while you want to go in and see that things are not going haywire. You know, that's
Or
it.
if the validation starts failing or something, then you go back and retweak it, I suppose.
Correct, correct. Because if the data fundamentally changes, for example, right, that could happen. But otherwise, it's this is the way we have architected is to do this on a constant basis without having to repeat a lot of these. In fact, if you have the best model parameters today, tomorrow we actually start with what we ended today, as opposed to starting from scratch. So even the computation aspect of tomorrow is going to be much simpler relative to what it would have been otherwise.
Right. All right, big question now. Bias. Let's talk about that, right? So real world data is often a mirror of the society's bias, as they say. And then when we are generating synthetic data based off of the real data, I would assume that there is some level of like bias automatically incorporated into it, right? So does synthetic data offer anything better than reality when you like have this new data set, or do you correct for those kinds of biases and make sure that you're training fairer, more equitable AI models and all that? What's the balance here?
No, that's an awesome question, Dinesh. I know bias comes in so many different ways, right? Because most of the data everyone has is very typically biased, right? You may have a buying pattern, or you may have financial transactions.
Who's buying it and all that, right? So everything matters. Yeah.
Everything matters, right? The beauty of what synthetic data offers is you can really mitigate bias using synthetic data. But of course, it is in conjunction with the human being or the domain expert that is working with the data, someone with knowledge of that. So, the simplest case is you take a data set, synthetic data replicates it, right? It contains all the characteristics. So if the original data has X amount of bias, synthetic data, if it is good fidelity, it'll have X amount of bias as well, or close to X, right? Now, that's the beauty of synthetic data is now you can go in and say, you know what, hey, this data, the fraud patterns of people who live in a certain region or people who have certain FICO score and all that, is very, very different. Now, can I change it in the synthetic data? Now I can go in because I've learned enough about it, the learned patterns and whatever, I can actually amplify that, right? So I can create more of, or more or less, we can do both ways, of certain patterns or certain aspects that will help mitigate the bias for you. So if you want to really share a more unbiased data set with somebody for or analysis or training a model, you can really generate synthetic data to augment what you have or create a set that can mitigate bias big time, right? Big time. But you
Right.
need to know what it is, right? If you don't know what it is, then it becomes hard to do in that case. But most people in most of this types of data sets, they do know what is the bias, why is bias happening, and now can I kind of generate a more balanced data set?
Mm.
Now, does my model reflect that? And you can also create scenarios and test corner cases as well. That's the other advantage of having synthetic data.
Right. No, and I can think of like, several such verticals like mortgage industry or like a hiring recruiting industry or like so many other places where bias would play a major factor. And then, as you said, maybe we can tweak up or tweak down the bias once we learn and all that. But I don't know, ultimately it is a generative AI model that is actually helping do this thing. So not sure where the real balance of control is, right? So something that I'm very fascinated by. I mean, you obviously have seen this much up front, closer to the ground and all that. But something that I'm reading up and learning myself in. It's really fascinating to see this. So, okay, now that you've been there in the space, running this company for like 3 years, what do you see as like the current challenges for synthetic data? Like, how are you approaching them? Um, what is like facing Rockfish in terms of like headwinds? How do you classify them?
Yeah, Dinesh, if you have like 4 hours, just kidding. So, there are two areas that we are addressing, right? One is, as you mentioned earlier, training AI models. And the second is agentic AI has become, the buzzword or buzz phrase
Right,
nowadays. Everybody is developing an AI agent. Um, in the case of model training, I think like we discussed, the problems are very clear. Either you don't have the data because of privacy reasons or the sparsity, and you can sort of using synthetic data, you can address both of those. In the agentic AI case, there are a whole bunch of interesting problems that are out there, right? People have developed an agent. Now they call it the demo to production death valley, right?
mm,
It's all great for a demo, but when you want to roll it out into production and make it work very robustly, there is a huge uplift, right? Seeing ROI, and then you want, when you deploy agents, you want it to be more predictable. Enterprises like predictability, right? Or sort of deterministic approach. Whereas with an AI agent, we still don't know. And the reason
right,
is they don't have the right data, the right scenarios that they go through, the workflows and what the expected outcome is, and can they test it and all of that, right? It's chicken and egg problem.
right,
I can't test it until I'm deployed, but I can't deploy until I've tested it, right? So we are, aiming to break that chain for agentic AI vendors and for enterprises that are deploying it. And with synthetic data, we can create those scenarios that they can test it with, and they can be confident that it'll work in at least a certain level of that, right? That's one. The second for them is, like you mentioned, things that are passionate in your sort of vantage point, trust, reliability, explainability, bias, and all of that. So taking bias out of the picture here, you also want, when an agent does certain things, you want it to be explainable, right? And you also want the performance to be very, very consistent as it does similar tasks or similar kind of environment. So using synthetic data, we can really position for some of these things as well. And for, of course, the
mm,
you asked about headwind or challenges. I think a startup like us were, in the process of finding product market fit. It's about trying to focus on which use case, which vertical, and how we sort of demonstrate consistent and repeatable value there. That's a non-trivial problem, and I think we are addressing that and going through that as we speak, right? Obviously, we have a lot of good customers, a lot of good partners, and to help us find our thing through this, right? So we're doing that. The second challenge in front of any company like us, in particular for us, and generally true for anyone like us,
Sure.
is talent. Finding really good people. We do the model of forward deployed engineers, right? Our AI ML engineers work directly with customers.
Mm,
That way, they can be very effective. They can understand the problem firsthand and they can solve it for them. Especially the solutioning part becomes a lot easier when that happens. That means we need a lot more AI ML engineers, and they are the hardest commodity to find these days, right? Commodity, I use it in a good
I
way.
know what you mean.
Yeah. So that I would say, and then third is again, there are lots of problems to solve. Sometimes it's tempting to go after all of them. But as a startup at this stage, we have to kind of say, I'm going to do this and then leave all
Only
the rest.
narrow focus and
Yeah. So that
focus on the niche.
exactly. That's never easy.
Yeah, I know what you mean. All right. This has been fantastic. I just want to like wrap it up with like one last question. From you being in the technology space for like this long and now running this company for 3 years, particularly synthetic data and all this happening all around us, what's the next wave of innovation that you are excited about? And what do you think is going to happen? Synthetic data, model training, and all that. Like, what's the next big thing that is going to be announced by, I don't know, you're probably hoping, expecting something?
Yeah. Wow. I mean, that's a tough question to answer, but let me take a crack, Dinesh. I really think that we spend a lot of human cycles in solving every AI problem today. Everything from labeling to model training to everything else. And I think that if we can automate all of that and make it work without any such problems, that'll be the greatest innovation next time. I think right now we have
Models, training models.
training models, labeling data, seeing value out of it. Because AI, ML engineers play a lot of big role in this, right? In all of these steps today, solutioning it, making it happen. I think being able to do this automated, right? Just everything just works like a charm, end to end. I think is going to be in my opinion, that's going to be the next big innovation. Right now, we have pieces of it, but still a lot of people involved. There are people involved in all of this stuff, right?
Awesome. Awesome. Fish, this was a great conversation. Thank you so much for sharing your insights about synthetic data, about Rockfish, and the industry in general. Loved learning quite a bit about some of these insights, and then I'm going to like do some more digging and learning myself after this. But wishing you and the Rockfish team the best of luck, and look forward to all the innovations coming out of your team.
Absolutely, Dinesh. Great talking to you. Very insightful. Appreciate it.